there's like a Mac version for Google Earth.
Yeah, because I was able to download it. I don't remember what I had to do though.
I'll Google it. How to.
I guess there should just be. I guess it doesn't really matter. There should just be the one download.
I'm downloading it right now. So
Sweet.
how are you guys doing?
Excellent.
So how does this?
Okay, I got it. It's downloading now. Are we gonna like screenshot it and turn it in, or he just watches the video of us doing it?
So the video only records us talking. It doesn't record what I have going on. It doesn't record what we have going on our screens. So let me look over it again. It says, as a group, synchronously work on plotting up the earthquakes that fall along a transect across the Marianas Trench and into the Sea of Japan. So maybe we screenshot it and then write or like put text boxes.
I mean, you can save a file, like the actual Google Earth file, and then someone else can open it and look at it. Pretty clearly.
So can you edit what you're looking at on Google Earth? Can you write things or?
Yeah, you can edit it, like put in pins and stuff.
Oh, I didn't know that.
So this is actually my boyfriend's computer, and I download it because I don't have his password. I can't download.
Joseph, were you able to download it?
So you can create a document like invite. You're saying?
Yeah, you can turn it into an actual file. Like there's a save option and everything. And I guess there's also a save image. That might work as well.
Are you guys talking about Google Earth?
Okay.
Yeah.
You know, we could just take a screenshot of it and put it in the same probe or whatever that we were doing last time, and then we can draw on it.
Yeah, we could also do that. There is options where you can like put in place markers and pass in Google Earth.
Whichever one's easier.
Yeah, I mean, it doesn't matter in the end. Whatever you guys want to do. What? So what's the? Well, I'm trying to figure out what is the. Are these like earthquake marks already in here? Is it these like I don't know, small dots? Never mind, that's not it. Yeah, so like I downloaded the file and everything, but I don't know if.
Yeah, I'm trying to understand what the colors of the lines and.
Oh, okay. Boundaries.
I think the bigger the earthquake, and then the lighter the color, the less you're looking at. So
Would one of you guys mind screenshotting what you're looking at on a Google Doc so I can see what you guys are looking at?
Well, I wonder if one of us, I might be able to, I got both my laptop and my desktop pulled up. I wonder if I could stream what's on one of them. Let me test this. Isn't there a way to show what's on our computer or something like that? Oh, screen share, that's it.
you can just screen. You can go to
Oh, well, that's trippy.
yeah.
Oh.
Yeah, there you go.
Oh, it's okay. So you see my screen?
Mm-hmm.
Yeah.
Let me see if I can find this.
Are we looking at chapter 11 then?
I think so. I don't remember which one had the earthquakes.
Determining size of an earthquake. And the next one is like the Earth's interior. So, seismic waves, earth layers. 11.
Okay,
Yeah.
awesome.
Oh, that's perfect. Okay. I can see what you're looking at now.
And so we're doing whatever's over at the King of Japan. Oh, much better.
So, plot the depth of earthquakes against the distance of the surface. And note the size of the earthquakes as well. Earthquakes that fall along the trescent along the transmission.
Yeah.
Hey, Daniel, that yellow line that's running along that trench, mine's blue.
Yours is blue. Does it say that's a transform plate boundary on yours or convergent?
Well, that's you.
Thank you. Where does it say that?
So on mine, it shows on the left side of Google Earth. Like, do you see it on my computer? It says plate boundaries, divergence red, transforms blue, and then
okay.
yellow.
Yeah, so this is it should be a divergent boundary. Or, well, that's where it's blue. Maybe I just don't have that that setting on, and that's why.
Ooh, I don't want that. Yeah, maybe.
Yeah, so that's fine.
Where's the earthquake markers? That's what I'm trying to figure
Yeah,
out.
that's what I'm looking for too. I'm not understanding where they are.
And yeah, there's the Mariana Trench. So we're trying to create a line basically that goes. Where's the see? Sea of Japan. Okay, so we're trying to like create a line that's right here, I guess. But like basically everything along this yellow line is the Mariana Trench.
Okay.
Right?
Yeah. And then we want to go. It's the one that goes into the Sea of Japan, is what the
Yeah. So there's
we're asking.
right on that other side of Japan. So I'm guessing like we're supposed to mark it through this, like basically through Japan to the sea and then through the Mariana Trench.
Are those red dots your earthquake?
No, these I think they're volcanoes. I mean, it's a lot of volcanoes, but I'm pretty sure that's what they are because I looked at a few of them and said they were volcanoes. Like, yeah, this says it's Silicon volcano.
Okay.
Yeah, man, that's a lot of volcanoes. But I guess that's what they call it the circle of fire or whatever.
Yeah.
If
So I'm
you
trying to
have
go ahead.
do you see a tab that says layers?
Layers.
Layers, and then underneath should say gallery, and then there's a tab for earth.
What you're playing?
I'm looking at Earth. That's what I'm doing.
You're looking
Oh, are you? On
Earth?
Uh-huh.
oh, sorry.
Hey, this is where we live.
No, it's not. That's Japan.
I thought it was Washington.
No.
Then where's Washington?
It's not here. Washington is way on the other side.
We're on the other side
Uh-huh.
of state?
It's on the other side of the ocean. It's right there.
It's right there?
Uh-huh.
How? I thought it was still Washington. What?
Nothing.
What part counted?
So, at the depth quakes against distance along the earth.
This far. What if I counted like this?
No, we shouldn't do that.
This far. What if I did it like that?
Leslie,
Where?
there you are. Let's get your swimsuit on. Hurry.
So I'm not. I have all the earthquake file. It's all turned on and check marked, but I'm not seeing anything show up over here. Do you?
Yeah, I'm not seeing anything either. Well, it shows these like circles too.
So there's these little gray dots. If you look to your left or your right, I think you see that little gray one? Yeah, I think that's one.
I think those are just little information.
Yeah, it says passion for the ocean. Oh, what just happened?
Never mind.
What did I just click on? Yeah, it's just some like informational thing.
There are no earthquakes.
If only that worked.
And then there's this time scale bar up top, and I'm dragging that back and forth. Not seeing anything happen there.
Yeah, let's see.
I'm
It's like
gonna YouTube it.
not a bad idea.
Earthquake layers, is that what we're looking for on Google Earth?
Are you sure that you marked the earthquake test?
Hmm. Say what?
Are you sure you marked the earthquake?
You cut out every time you say it. What was it?
Yeah, nothing's changing except those little tabs on the screen,
Yeah.
which is interesting.
Does it have anything to this? Yeah, you guys were saying layers. Is there anything down here? I don't think so. Shipwrecks, National Geographic. Whoops. Did not mean to do that. Borders and places.
I mean, for me, they popped up. All the
Roads.
They did?
yeah, like a little orange symbol with like a line going through it.
Oh, is that it? Oh, I think so I clicked on
The orange.
more. I don't know if this is it, but it popped up all this random stuff.
Hey guys,
Yeah. Good.
so on the YouTube thing it says go under layers, click gallery, hit earthquakes, and then you have to zoom in all the way in the tabs.
Oh yeah, I see it now. Oh, I got it.
Yeah, and then you click on
There you go. Right there.
Then you click on what?
the little red tab. So click on one of those, and then it'll give you the information about that area.
Okay.
Oh, I got it too. Thank you.
Okay. And so if I move this, it's gonna change, right? Or no? Is this even the same? I don't know if this is part of the same thing because it doesn't have like the colors or anything.
Yeah, it just says the magnitude when you hover over them.
Yeah. Yeah, but yeah, I don't think it's the same thing because ours is supposed to be 2018, like this year, and these are from the last few years.
We can find the one that's 2018.
Yeah. Wow, 9.1.
Whatever that indicator
Wow.
is. Latitude.
I think these are supposed to be like bigger earthquakes because these are all like 7.1, 6.5. This really big one was a 9.1.
So, Kimberly,
Yeah.
on the home page for the geology class, Brother Shirtlift posted a video. I wonder if that has any information about this.
Okay, I'll look.
Well, I know there's like a when I was first looking it up.
So the file, it has a file we will use.
Oh, right.
So you have to click on the file.
Yeah, so we open that file that's attached there.
And then you can find several versions of the earthquakes KML file here. So then you have to click on this one and see. So that file is a Google Keyhole markup language. Download an animated earthquakes KML feed. Use the time. You have to download this thing for the time slider thing. Okay. So go into the home page where Joshua is saying? Josh, right? Is that?
Yes.
And then you have to download the KML file, and then you can get the thingy. What I'm talking about?
I think so. Is there only one file there? Because that's the one I downloaded.
Well, it says here's a file you're using Google Earth. At the bottom, it says you can find several other versions.
Okay.
And you click on that link, and then it'll give you a different link to download. Sorry. And it will be the earthquake animation stuff right there. Ah.
Are you watching the video or are you just reading it from
Let
that?
me show you. How do I read? Doesn't Can you go into Google Earth and open the KML? Right there, you see what I'm saying?
The USGS KML file?
Yeah, so after you download that link that he already gave us, you have to go into Google Earth and open the KML file. Select earthquake.
Working for me very well. Oh, sweet.
Are you reading this or am I?
I'm looking at it. Are you, Daniel?
Not yet. Sorry, my double my other computer. Okay, I'm gonna stop the file sharing on this one and see if I can do it on the other.
So, Dan, can you go onto your Google Earth really fast and see if you can open the KML file?
Yeah, wait a second.
And then this is what should or we get it.
Did it work?
I can't download the Google Earth
Hmm.
because I don't have a password, but this is what it's saying to do.
Yeah, so I downloaded that KML file that he had on the home page. And
Yeah, I have to go into Google Earth.
Okay, so I'm in Google Earth.
So look for the KML file.
And I open the KML file. So I have the earthquake showing, and I'm moving this time bar back and forth, but nothing is happening.
So go to the left navigation and select earthquake feed. Do you see that?
Left navigation.
And select earthquake feed. That's what you're looking for.
I think I have it selected. Maybe not.
How to select earthquake
Oh, but my slide bar is also stuck on June 14th. Like I can move it and it moves between 724 and 725, which is weird. Oh wait, let me see this here.
Downloading normal KML feed to view big data. You will have to re-download the KML file to access updated. To view earthquake animations, follow the directions. Okay, I'm going to show you a video that shows you how. Ready?
Yeah. Okay. Sorry. I had to mess with my computer a little because it was freaking out.
That will automatically update to show you the most recent earthquakes that are going on. It updates every 5 minutes. But first, you want to go to this website, earthquake.usgs.gov. United States Geology puts this out. /learn/kml.p. Once you're at this website, first off, if you don't have Google Earth, there's a link here so you could download it. If that's helpful. This activity, so you want to download it onto your computer if you can. Download it, and once you're ready, then we'll move ahead. So some of the other features that are on this page, there's some pretty cool things. Like I said, we're going to focus on the real-time earthquakes. One other thing I wanted to point out, well, all of these are interesting, but the tectonic plate boundaries, you could put that into Google Earth, so what tectonic plate boundaries are, what type of boundary they are, labeled by color. So anyway, there's some really good things on here. We're going to focus on the real-time earthquakes. So mostly what's on this page here, the majority of the text is just description. So if you want to learn more about KML file type, which is what you use the information to learn, read more about it'll tell you about how to work the scroll bar for the earthquake animations that you can download. But the most important information is right here on the right side of the page. So we're going to look at automatic feeds, but there's also static feeds. The difference is automatic feeds will update automatically. So every 5 minutes or every 15 minutes, depending on which option you choose, it's just going to update the database. But static feeds, not auto update. So this is the option of keeping the data as you wanted it for a certain day. So you could download it for that day, but it won't change unless you want. So what we're going to do is just go ahead and download the past 30 days, because the past 7 days may not give us enough information to look at. So I'm going to go colored by depth, because I think that's a good thing to look at. So if you click on colored by depth, it should download your file type. Keep in mind what the name will be able to find it. Open Google Earth.
So can you pause it real quick?
Yeah.
The past 30 days one.
It's on
Let's see.
that file.
So did he click on real-time Earth? Oh, okay, here we go. And then did he hit colored by age or
By depth.
by depth? Okay.
And then it downloads on the computer. Got it?
Okay, got it downloaded.
Here. Start with
And then he opened it.
first file in. First thing you do, it's really easy. You just go to File, Open.
File open.
And then you find this file. So if it's in the Downloads folder, get it from there. Or if you saved it somewhere else, find it from there.
So go to your downloads and then open that file that you downloaded.
Okay.
Got
Yeah, I got it.
Open or double click it. And atmosphere. Especially over here on the coast of California, there's a whole
Okay. Pause it again. How did he get those dots pulled out?
So did you download the?
Yeah, so I downloaded the file and I opened it.
So what pulls up?
Looks like what he's got except the time bar up top. I have the time bar.
The magnitude thing.
Yeah, I have the magnitude thing, but I don't have any of those earthquakes popping up.
Can you flip your screen? Can I look at it really fast?
Yeah. The screen share, is that it?
Yeah. Okay, so just zoom in. There you go. Zoom in and it'll pop up.
Okay, there they are. Okay.
Because a lot of people are attributing that to hydraulic fracturing related to oil and gas production that's going on significantly around that area. So some pretty good evidence about fracking creating earthquakes. But that's okay. But anyway, you can see the orange dots are related to earthquakes. So the reason they're all orange here is because they occur at a depth from 0 to 33 kilometers. So they're pretty shallow earthquakes. If you have deep earthquakes, they'll be a different color. And the magnitude of the earthquake is represented by the size of the circle. So the bigger the circle, the stronger the earthquake. So hopefully that helps you discern this map a little bit. So let's move from North America and let's go down to South America, off the coast of Chile and into Argentina a bit. I want you to notice a pattern here. So you remember what the colors represent. So the orange is the most shallow, the red is the deepest. So what do you notice as you go from the coast inland? So I want you to think about that pattern here. Your earthquakes are more shallow near the coast, and as you go inland, they're deeper. I want you to think about why that might be, specifically considering the tectonic boundary environment. And if you want to know what type of tectonic boundary this is, probably a good idea to download that other feature that I showed you, the tectonic plate boundaries. So you can download that and take a look. See if you can figure out why the earthquakes will be shallower on the west coast and then get deeper as you go in.
Got it? We good?
Okay, so I have them all pulled up and I see the earthquakes now.
Okay, cool. So if we need different ones, like the age or things like that, we just download each one.
Oh, okay. So it says plot the depth of the earthquakes against the distance along the surface and note the size of the earthquakes as well.
Okay, so let me look at someone's screen. So is that all we have to like?
So I wonder if we plot just these or let's see, against the distance along the surface. Against the surface of what?
Oh, like how deep they are?
I guess so. Plot the depth, not the size. Does he? Was that was the end of the video? Does he not go through the prompts here about what he asked? Like,
No, that was a YouTube video.
oh, that was YouTube. Okay.
I'm gonna Google the question. See if we can find.
Because he has a video on the geology page. Um, yeah, so if you pull up his video, if you go to the geology page and play the video, it looks like he starts off with this group activity and what we're supposed to do.
Welcome everybody to another exciting overview video. So, what we are going to learn about today is earthquakes, and there's a couple different Google Earth files that we'll be using in this video and in this week. So,
Is there a way to like increase the time, how fast he speaks?
what you're going to be doing is looking at
I don't know how to do that.
Oh, okay, that's fine.
quakes that fall along the Marianas Trench, and you're gonna look at the earthquake's depth versus their distance from the trench,
From the
and
trench.
see if we can find out a little bit more about the data.
Oh.
So, you get a Google Earth file, and you can find that file on in the course announcements that will be posted. And it looks something like this. So you'll have here.
Okay, if you want to pause it. So if I click on these earthquakes, it'll give me a, well, I can see what their magnitude is. And then I can also measure what their distance is from that trench. So do we just want to choose 4 or 5 of them that are noticeably different distances from the trench and just plot those in Excel?
Yes. Sure.
Okay, let's do that.
So when it's collapsed like this,
So
we show you earthquakes.
are you gonna do this on there, or can you shot and then we can do everything?
Yeah, so open something up on the drive. Is that what you were saying?
Yeah.
Yeah, so I'll open something on the drive here and I'll share it with everyone. Okay, I just shared a Google spreadsheet with you.
Yeah, are you guys able to hear me?
Yes.
Yeah.
Are you guys able to hear me?
Yeah, we can hear you.
Yeah.
Okay.
Are you?
So you're gonna put the picture in here?
What were you saying? Sorry.
We're gonna put the picture of the map in there in the Excel
Well,
file.
just a minute. Let me. So it looks like, I watched a little bit of his video, and he was just, for that first question, that first bullet point, he was just plotting different numbers in Excel. That's what I figured we could do here. I don't think we need to post a picture of it. So what I'm going to do is I'm going to look at my Google Earth. I'll pull that up. And we have these earthquakes here if you look on my screen. So if I'll just look at the magnitude of that, and I'll measure the distance from this trench, and we'll just plot those.
Okay.
So Joseph, if you want to type what I say, and I think this is what, because this is what he was doing on the video. I think this is what he means, unless anyone has any other ideas. Are you figuring anything out over there, Daniel?
That's what you said. Sounds good. So you're saying like just measuring between and plotting that.
Yeah. So see all these purple dots? So when we're right on the trench, the depth of our magnitude. Wait. Okay. Our magnitude does it get bigger as we go out from the trench? Or am I just seeing things?
I mean, I don't know if it like the same.
Can you measure in there?
Measure what?
Can you measure?
Yeah, there's a way to measure. I'm just trying to find where the do you know where it shows the magnitude, Daniel? Do you see that?
I mean, if you hover over the dot, it shows it. So it says like magnitude 4.0 for like.
Oh, okay.
Depth, and then like the size of it is the magnitude, and you hover over it, it tells you what.
Okay, I see it. So there's really
most of them
like in the 4 range.
Yeah, they're all.
So there's really not much of it.
30 days. Yeah, I mean it's only from the last 30 days, so unless anyone's heard of like the major earthquake thing.
Did you guys share an Excel spreadsheet? Thingy?
What was that, Kimberly?
Did you guys share like an Excel spreadsheet?
No, that's all there is there. So I figured we could just type up. So it looks like we'll plot these things, and it says, and then we can just type up what trends we notice, how we explain these trends, what we'd expect to see if we went further inland, and so on.
And the graph. And then write the trends underneath it.
Oh, we're supposed to make a group.
Yeah, in the video, he's just plotting them on Excel and then making a graph with the data. So, how do I do this? Okay. What's your guys' email?
So I'm confused because I'm not seeing a big difference of magnitudes in these earthquakes.
So then,
So
what you're supposed to put on there is the depth and the distance from the trench. That's it. We plot it, and then we graph it.
So the distance from the trench and its magnitude, or just the distance?
The distance and the depth.
Okay. Cool.
So, do you guys know how to do distance?
Well, for the kind of, do we kind of just say under how deep it is, or do we have to
So you click on the
kind of
symbol
take in?
and say depth right there in the little pop-up box.
Okay, so if
And
you look at my screen, so there's a magnitude of 4.9 here, and the depth is 21.75 miles.
Gotcha.
so distance, you're gonna click on the ruler up above, and you're gonna there's like a little ruler line, and you measure it to the. And I don't think you're on the right thing. You need to go in the search bar, Josh, and then type in the trench name.
Yeah, so the Mariana Trench is right here.
Oh, okay. So we're just supposed to plot those ones that are up.
Yeah, it's because this is a trench. And this is the Sea of Japan. And that's what it talks about. So I think it's just these ones.
So the ones he's plotted are. I'll show you.
Right? And you're just gonna keep doing this with as many earthquakes.
So
as you
these
can
are the
find
ones he's
here,
plotting right here, where Guam is.
so you can get a sense of, and especially things like this week.
Okay, yeah.
He wrote
Sorry,
that.
guys. I was only hearing like every other word, so I switched to my phone.
So basically you'll be looking at each one of these and recording them, and then you'll plot in a graph the depth versus the distance.
Distance. Okay.
Your data here.
Did you guys get that?
Yeah, I think so. So we need depth versus distance, and we just choose some of these earthquakes over here and just plot them. Well,
So
okay.
the depth and then the distance from the Mariana Trench.
Yes.
Okay, so that's simple since it already shows the depth, and then to show the distance, there's a thing near the top of Google Earth that says add path, and I'm pretty sure we can use that to find distance. So if you just click on the dot, or I guess is it click and drag? Oh, never mind. So you just click once.
Yeah.
There you go.
Okay. Do you want to do it in kilometers, miles? What sounds good to everybody? Miles?
I'm fine either way.
Yeah, whichever.
Okay, miles. So I have these earthquakes that are on Japan. Are those the ones we're looking at?
I guess so. He did mention the Sea of Japan, like he wanted to transect around to transect the Sea of Japan or something like that.
Yeah, so
In the Marianas Trench in the search bar, it'll take you right to the spot where he was plotting.
How do you spell Mariana Trench?
I have no idea.
Oh, okay, it's just Mariana Trench. There's no doubles. Okay, yeah. So at least where I guess where he was is where there's the little half circle around Guam.
Yeah.
Maybe he meant the Philippine Sea. I don't know.
Let's just choose
plotting.
one.
Do we
Yeah.
have a sheet shared with everyone?
Yeah, Josh just sent out a thing.
Oh, he did? Oh.
What does he mean a transect across the Marianas Trench and into the Sea of Japan?
Yeah, I don't know. That beats me.
So let's see. To cut across.
Maybe it's just where that curve is happening. The circle.
Okay.
Oh, so okay, I see what you mean. So it's not saying that we have to crater. So we're just plotting the earthquakes that are along, like probably along this yellow line that's on my screen. So everything that's along this yellow line. So we're not like creating it anything. It's just what's along here.
Okay.
Well, and probably so he might be talking about all the earthquakes that, that are coming up here. So all of this.
So, okay, because that goes across into Japan. So what if we just do that upper part? Because that's a lot of earthquakes.
What were you saying?
So how about we just start up above that curve and go from there? Because
Yeah,
a lot of earthquakes all the way through it. Okay, so Daniel, do you want to start clicking on those and maybe I can start recording what?
Okay, yeah. So we'll start with this purple one.
Hey guys, so I have to go because tomorrow morning. So sorry I couldn't be much help.
That's fine. No, we'll try to finish it up quick.
Okay.
So thanks, so Joseph. Yeah, it just took a while to figure out what's being asked.
Yeah. All right. So next week it's Thursday, back to Thursday, or
Yeah, that should be fine.
Okay.
Okay.
Awesome. Then next week.
Okay. See you, Joseph.
Yeah. Bye.
So this first purple line, this first one, this purple one is 145 miles. So, and then the depth is 300 to 500.
3025.
Say what?
Oh, feet? Wait. 302, 500?
It's 300 to 500 kilometers in depth.
Oh, I see. Okay.
Yeah, according to the
Oh, so
thing.
if you click on it and it should say it on that pop-up. It says,
Oh, really?
Yeah.
Oh, so it's 317 kilometers in depth. Or if we're doing miles, it's 197.4 miles.
Okay, 197.4. And what's the distance?
Okay.
And what was the distance again?
Give me a second. So let's see, number. Yeah, how do I bring up these lines again? Oh, here we go. Okay, give me a second. So it was 145 miles.
Okay.
And then for the second one, it was 119 approximately. It's kind of rough.
Yeah, that's fine.
Call this number 3 right here. Okay, so this number 3 is 22 miles in length. I don't think we have to bother with this one. It's like, I guess we can do the small. I mean, it's right on the Mariana Trench. I guess it depends on.
Nah, it's fine. It doesn't have to be exact.
Yeah. I mean, it's right there. So, yeah, that one's. The fourth one is right on the Mariana Trench.
Its depth.
So number 4 is 6.21 miles. And the number 3 is also 6.21 miles.
Okay, wait a second. Wait, 3 and sorry, I got lost. So 6.21 miles and the distance is 22. And then what was the other one? 6.21 miles for the depth.
Oh, which one?
You're the number 3 and number 4.
So number 3, like the distance. So the distance for number 3 was 22 miles. Number 4 is 0. It's right on it.
Okay. I guess I got lost on my spreadsheet here.
Let's see. Number 5 is the distance is 199 miles.
And its depth?
Give me a second. Its depth is 230.8 miles. Oh, dang it. It just disappeared from me again.
So I'm starting to see a trend already that the farther the distance from the trench, the deeper the earthquake is. So we can probably
Yeah.
So we can probably just choose a couple more random spots, and then I'd say just answer the questions from there. But
Let's
that's
probably get a few other different colors.
Yeah.
Okay. Okay. So let me try. Did you record that I had a number 6?
So the last one I had is a depth of 230.8 and a distance of 199.
Okay, so I have another one that's a distance of 219 and a depth of 305.
Okay.
Okay, there's a orange and a green right here. Seven. Okay, so number 7, the length is 54. And the depth is 6.21. That's weird. A lot of them have been like that same depth.
Yeah, that's strange.
Okay, this one should be different. Okay. This is number 8. Number 8 is basically 89 miles with a depth of 60 miles.
Sweet.
Okay. The
Earthquakes. Earthquakes. All right, guys. Well, I'm gonna head out.
Oh,
Okay, sounds good. Thanks, Kimberly. I don't think so. We just got to answer these few questions. Should be good.
Sure. Do you want me to make the graph for these numbers?
Yeah, that would work.
that would be fantastic.
Okay, I will do that then.
And yeah, I mean, you don't have to do it tonight. You can do it whenever. But...
Okay.
That'd be awesome. And
Okay,
then
bye.
so yeah. Daniel, is there any others you're wanting to plot?
Sure, we can do one more. Number 9
Okay.
is 84 miles. It's got a depth of 225.5 miles.
Sweet. Okay, so what trends do you notice in the data?
Like what you were saying before, the farther away it is, the deeper it is. Let's see. Is there any red ones?
Yeah, I haven't seen any over here.
Yeah, there's none by the Mariana Trench. They're all way far away. And I mean, like, for something to, like, that would act, at least I feel like as a matter of relevance, like, something that deep is probably really powerful, but, we can't even feel the full,
we don't.
power of it.
Very true. So how do you explain those trends? Why would it be that the greater the distance from the trench or the less depth?
That's a good question. Well, I don't know. I'm kind of.
Oh, I know. Because if this is a divergent boundary, and it's oh no, it's not, because this is a
convergent.
Yeah, this isn't a ridge. Never mind. That isn't it. I thought I was onto something.
No, well, you might be. Well, so if you have two plates coming together, and there has to be some kind of force driving the two plates as well. So it might have to do with that.
Yeah. Yeah, so maybe where the plates collide.
Well, I guess when you think about it, like when you have like these two plates coming together, and they're coming together like this, like that point where they're like turning, as they like bend in on each other, those points where they're bending is probably where the earthquakes would happen, not necessarily at the actual spot.
Yeah.
I don't know if that makes sense, because I feel like they're not really colliding when they come together. It's more like
one subducting underneath the other one.
Well, I think because they're both coming together, because it's convergent. I don't know if one's necessarily subducting under the other, but it's like they're coming together, and it's not necessarily. It doesn't really seem like they're colliding so much as like they're.
Okay.
Like they're both going under together.
Okay.
But I feel like it would be the bending, like where it bends, is where all that like slippage is gonna occur.
Okay. No, I see what you're saying now.
Yeah, I don't know if that makes sense.
I don't know if I could. Maybe you might try writing it in words, but I see what you're saying, where they start bending, which will be higher above the ground.
Oh, wait.
More.
Yeah, actually, yeah, I don't know. Well, now that I think about it, that doesn't really explain why. It doesn't really explain the depth, though.
Yeah. Maybe it's just because all the forces that happen when they converge might just be a lesser depth. I don't know. Not exactly sure.
Well, I wonder. Let me pull up the. Actually, I want to see this. I'm gonna pull up the volcanoes and wonder if that might have something to do with it. Let's see, where's volcanoes? Oh yeah, dude. So that's interesting. Did you download the one that has the volcanoes and stuff?
I just pulled it up.
Yeah. Well, it looks like a lot of the earthquakes are happening closer to the volcanoes.
Oh, rather than the trench.
Yeah. Well, and I mean, look at if you follow that like the ring of volcanoes all like up towards the north, like you can see like all of the earthquakes. It's
They
not happening around the trench so much as it's happening around the volcanoes.
very true. Huh.
Except for that, wow, that's weird. There's a spot near Kodiak, Alaska, where they have a ton of um, earthquakes that they've recorded. But yeah, so it probably that would probably be my best theory is that it doesn't have to do with um, the plates colliding so much as it has to do with the volcanoes. One,
No, the
the
volcanoes.
volcanoes. What?
Yeah, the volcanoes are there because of the plates
Yeah.
colliding.
Okay, that would make sense.
Too.
Well, and this that so maybe what you were saying before, like one's going under the other, like so they're colliding together, but one is like going right under the other. So, like if we're looking at this right to left, like the right one would be going under the left, and
Yeah,
then lava would be coming up through the right plate.
because I think with the continental oceanic convergence,
Oh yeah, that's
the
right, that's
oceanic
right.
is more dense. It goes under the continental.
Yeah,
Um, hmm. And if you look, all these earthquakes are seem to be on the left side of the
yeah,
trench.
yeah. That makes sense. Yeah, so the right plate's going on that.
Yeah,
I don't know if I'm thinking of it the right way, but the right plate's going under the left,
yeah,
and
that's what I.
then like volcanoes or like the magma's heating up through the plate and going to the top because of that. It's what do they call it the when a cool plate goes into um comes in contact with heat?
Um,
It's like melting or something like that.
yeah, I don't remember.
But I mean, either way, so it's like that cool plate is, it's heating up and because of the water content, it uh,
Faster.
heats up faster, and the lava comes up through the plate, rises to the top, and that's what causes the volcanoes. So that would explain why all the earthquakes are happening on that side, and why that explains the depth too, because the farther the way away it is from that convergence, the farther down the plate is.
Oh yeah, if they're all coming off that oceanic, that Pacific plate.
Yeah, and I mean, also notice I didn't think about this before, but it does seem like the greater the depth, the smaller the magnitude, which makes sense because it's not going to have as big as an impact at that depth. And that would also explain why the Sea of Japan doesn't have any earthquakes. I mean, there's nothing there. There's a few volcanoes, but other than that, there's nothing near the Sea of Japan. Okay. Yeah, and you can see like if you go way farther north, it seems like there's way more earthquakes, and it's that same thing where most of them are on the left side.
Yeah, that's strange.
if you go farther to the south, it switches and they're on the right side. Oh, at least for a while. Okay. What would you expect to see if you went further inland?
Well, that's a further distance from the trench, so wouldn't they be even deeper?
Yeah, that I would assume that. If you look at Japan, though, they're not.
Yeah,
Yeah,
it's
if you look at Japan, they're not quite as deep.
yeah, they're not that deep at all.
Well, and I wonder if some of that has to do with it being so maybe it's not like oceanic and oceanic crust. So maybe like, down low, that's like the two pieces that are coming together is oceanic crust, whereas up here near Japan, this is oceanic and continental crust.
Yeah, because maybe these earthquakes we see that are all on the left side of the trench are coming from that oceanic, that Pacific plate when it's being pulled under, explaining why they're the further the distance, the deeper they are. So maybe these earthquakes are on this continental or this plate that Japan's on. So it's not subducting underneath anything. So they're not as deep, if that makes any sense.
Yeah, I think I get what you're saying. What are you saying? So like the plates have a reversed position, so instead of the right side, it's the left side that's going under.
So no, not because the left side I'm saying is
Yeah.
staying above the right side, but I'm saying that the earthquakes that are all next to that trench are all being subducted from the continental.
Yeah. Okay.
Like,
Just
but
making sure.
yeah, the ones inland aren't being subducted at all, so they're not as deep. And I don't know if that's true. What to look at it.
Okay, I get what you're saying. Well, yeah, and I mean, like what I was saying, it might just be that part of it is that it's continental crust rather than oceanic crust.
Yeah. So we'll say we'd expect them to not be as deep because they are continental crust and okay, yeah.
At least that's what I would assume.
Yeah.
Never realized how close Japan is to some of the other countries. It's not very far at all. Like South Korea and Japan, it's not very far. Anyways, let's see. What would you expect to see if you did the same thing along the trench near the Solomon Islands? Where's the Solomon Islands? Oh, okay. So Solomon Islands are to the east of New Guinea. So this is when I was talking about. So near the Solomon Islands, it's on the opposite side. So rather than the right plate being subducted under, it's the left plate that's being subducted under.
Huh.
But I mean, either way, I would expect the same thing.
Yeah.
The farther away it is, the greater the depth. It looks like for this though, it's really uniform. Like there's a couple of variations, but other than that, um, like, well, I guess it's not uniform, but it's like there's not really any relevance to it. Like some places it's deeper, and some places it's not, and that might have to do with location in the case of Solomon Islands, because in like one spot it's all blue, and then another spot it's all green.
Yeah.
So it looks for the Solomon Islands, it's just a matter of, it's not so much about how far it is, but where it is. But it's the same idea, but this time it's the right plate,
The right side,
or the
yeah.
left plate that's being
Left,
subducted
yeah.
onto the right. And then what else did they say? What about the Himalayan mountains? Well, the Himalayan mountains is different because it's continental crust coming together, isn't it? So I would imagine it's not as big as an earthquake area. Yeah, see, if you look at like the where's Mount Everest? Can't even tell. Oh, is that it right there?
You can see the few earthquakes there are right on that, where those plates are colliding.
Yeah. Yeah, well, and it's colliding like basically between China and India, right?
I think so.
Yeah, so I always imagine like the Himalayas was just this big like blob, but it's more like a crest that comes between China and India. So it kind of makes sense that that's what is happening, is two continents coming together rather than like something else happening.
And if you look at the earthquakes that are farther away from that ridge, the Himalayan mountains, they are deeper than the ones that are on the Himalayan mountains. So it's the same concept.
Yeah. It doesn't look like there's any like on the side of India though. Like, so they're all more towards China, at least from what I can see. I don't know if I'm seeing everything. I can't even spot Mount Everest from here. Trying to figure out where it is. Oh, it's right there. Oh, that's weird. It's like from the perspective, like a 2D perspective, like it doesn't look like it's very, like the elevation's very high.
So for the Himalayan mountains, I just put that there's similar results because the earthquakes on the Himalayas aren't as deep as ones that are farther away.
Yeah. Okay.
What are you looking for?
I was just kind of looking at like the area. I did notice something interesting. So like on the side of India, it doesn't look like it's quite as mountainous as it is on the side of China.
Oh, yeah.
Oh, that's cool. I didn't know I could do that. Man, from here it looks so insignificant from Google Earth, but it's like in real life, this is
Huge.
it's huge.
Yeah. Cool. Well, anything you can think of? Anything else?
I don't got it. I don't have anything else
Yeah.
that I can think of.
Glad we finally figured it out. Thanks for sticking around.
Yeah, no problem. My pleasure, man.
Okay, I'll see you next week. I'll put the YouTube video on the Google
All right.
Doc.
All right, sounds good. Thanks, man.
Okay.
You're the
Yep.
best.
See ya.
See ya.
Bye.